Hello dear students, in this video I'll continue with the 7th unit financial mathematics. Here I will discuss about nominal and effective rate of interest and solve the questions from exercise 7.4 of CBSE Handbook. First we will see what is nominal rate of interest and what is actual rate of interest. The announced or the stated rate of interest is called the nominal rate of interest. Say for example, if the stated rate of interest is 6% per annum, then the nominal rate of interest is 6%. The effective rate of interest is the rate by which the money grows during each year. It is called the effective rate of interest. Now say for example, if this 6%, if it is compounded say monthly, then the effective rate of interest, it will be different from this 6%. Now let us see the relation between effective rate of interest and nominal rate of interest. Let us take let R be the nominal rate of interest compounded m times in a year and REFF be the effective rate of interest. Here since R is the nominal rate of interest which is compounded m times in a year, we have the rate per period I as R upon m. If we take the P, the principal is rupees P, then this principal P, it amounts in 1 year to P into 1 plus R by M, the whole raised to M. And if you see the effective rate, it is the actual rate which is compounded annually. Therefore, at effective rate REFF, the principal P amounts in 1 year to P into 1 plus effective rate. So from this we have here the principal P amounts in 1 year to P into 1 plus R by M the whole raised to M, and here the principal P in 1 year amounts to P into 1 plus effective rate. So from these two we have P into 1 plus R by M the whole raised to M. It is equal to P into 1 plus R effective. So these two P's will cancel. Or we have 1 plus R by M the whole raised to M equal to effective rate plus 1. This implies the effective rate is equal to 1 plus R by M the whole raised to M minus 1. So if the nominal interest rate is compounded M times in a year, the effective rate of interest is given by 1 plus R by M the whole raised to M minus 1. And now we will see if the nominal interest rate is compounded, if it is compounded continuously. Now we just now saw R effective is equal to 1 plus R by M the whole raised to M minus 1. Now if this R is compounded continuously, then we have R effective interest rate is equal to limit M tends to infinity 1 plus R by M the whole raised to M minus 1, or this is equal to limit M tends to infinity 1 plus R by M the whole raised to M minus limit M tends to infinity 1 is 1 itself. So here I am multiplying and dividing by R. So here we will have limit M tends to infinity 1 plus R by M the whole raised to M by R the whole raised to R minus 1. So let us take let R by M equal to X. If we take if R by M is equal to X, then as M tends to infinity, as limit M tends to infinity, X tends to 0. Then as M tends to infinity, X tends to 0. This implies we have the effective rate as limit X tends to 0, 1 plus X the whole raised to 1 by X the whole raised to R minus 1. Now this limit x tends to 0 1 plus x the whole raised to 1 by x the whole raised to r. It is the definition of exponential function. So this is equal to e raised to r. So this implies effective rate is equal to e raised to r minus 1 if the nominal interest rate r is compounded continuously. So these are the two formulae that we have to remember under effective rate of interest. So effective rate of interest is equal to 1 plus r by m the whole raised to m minus 1. If r is the nominal interest rate and m is the number of conversion periods per year, and in case of continuous compounding of nominal rate, we have the effective rate of interest as e raised to r minus 1. Now we will start with the exercise questions. So these are the questions from exercise 7.4 of CBSE Handbook. The first question, what is the effective annual rate of interest compounding equivalent to a nominal rate of interest 5% per annum compounded quarterly? So we need to find the effective rate of interest compounding equivalent to a nominal rate of interest 5% per annum which is compounded quarterly. So here the nominal rate of interest is given as 5%, and since it is compounded quarterly, we have m is equal to 4. Now using the formula, we have r effective is equal to 1 plus r by m the whole raised to m minus 1. So it is 1 plus 0.05 upon 4 the whole raised to 4 minus 1. So it is 1 plus 0.0125 the whole raised to 4 minus 1. It is 1.0125 the whole raised to 4 minus 1. This when we simplify it is 1.0509 minus 1, or it is 0.0509, which is 5.09%. Therefore, effective annual interest rate is equal to 5.09%. Similar question was asked in the sample paper for 2 marks. Writing the formula carries 1 mark and getting the final answer carries 1 mark. Moving on to the next question. Which is better investment? 3% per year compounded monthly or 3.1% per year compounded quarterly? So let us find the effective interest rate for these two options, and based on the value of effective interest rate, we can find which is the better investment. So when 3% per year is compounded monthly. So first let us take this. Here r is equal to 0.03 and m is equal to 12. We have r effective is equal to 1 plus r by m the whole raised to m minus 1. So it is 1 plus 0.03 upon 12 the whole raised to 12 minus 1. So it is 1 plus 0.0025 the whole raised to 12 minus 1. It is 1.0025 the whole raised to 12 minus 1. This is 1.0304, or it is minus 1, or it is 0.0304. This is 3.04%. So when 3% per annum is compounded monthly, our effective is equal to 3.04%. When 3.1% per annum is compounded quarterly, here r is equal to 3.1% or 0.031. and m is equal to 4. We have effective interest rate is equal to 1 plus r by m, 0.31 upon 4, the whole raised to 4 minus 1. So it is 1 plus 0.00775, the whole raised to 4 minus 1. Here 1.00775, the whole raised to 4. It comes out to be 1.03136 minus 1. So it is 0.03136. So here our effective is equal to 3.136%. So here we can see that when 3% is compounded monthly, effective interest rate is 3.04%, and when 3.1% per year is compounded quarterly, effective interest rate is 3.136%. So here this is a better investment. Therefore, 3.1% per year compounded quarterly is better. Is a better investment. Next question. What effective rate of interest is equivalent to a nominal rate of 8% converted quarterly? So here we need to find the effective rate of interest which is equivalent to a nominal rate of interest which is compounded quarterly. So first let us write what is given. Nominal rate of interest is 8%. So it is 0.08, and the number of conversion periods per year, it is converted quarterly. So m is equal to 4. Now the formula, effective interest rate is equal to 1 plus r by m, the whole raised to m minus 1. So it is 1 plus 0.08 upon 4, the whole raised to 4 minus 1. So it is 1 plus 0.02, the whole raised to 4 minus 1. Now this when we simplify, 1.02 the whole raised to 4 is 1.0824 minus 1. So it is 0.0824. Therefore, the effective interest rate is equal to 8.24. Next question. To what amount will rupees 12,000 accumulate in 12 years if invested at an effective rate of 5%? So here they have directly given the effective rate which is 5% and number of years is 12. So first let us write what is given. Given principal is rupees 12,000 and our effective is equal to 5% which is 0.05 and n is equal to 12 years. Therefore, amount A is given by P into 1 plus R effective the whole raised to n. So it is equal to 12,000 into 1 plus 0.05 the whole raised to 12. So it is 12,000 into 1.05 the whole raised to 12, or it is 1.05 the whole raised to 12 comes out to be 1.7958. Now this when we simplify, we get it as rupees 21,549.6. Therefore, amount is equal to rupees 21,549.6. So a sum of rupees 12,000 accumulated in 12 years at an effective rate of 5% will give 21,549.6. Moving on to the next question. Which yields more interest? 8% effective or 7.8% compounded semi-annually? So the first option 8% effective. Here our effective is 8%. First one 8% effective implies our effective is equal to 8%. Second option, when 7.8% is compounded semi-annually. If 7.8% is compounded semi-annually, here R is equal to 7.8% or it is 0.078. And since it is compounded semi-annually, so we have the number of conversion periods is 2. We have the formula R effective is equal to 1 plus R by M the whole raised to M minus 1. So it is 1 plus 0.078 upon 2 the whole square minus 1. So it is 1 plus 0.039 the whole square minus 1. It is 1.039 the whole square minus 1. Now 1.039 the whole square is 1.0795 minus 1. So this is equal to 0.0795 or it is equal to 7.95. So here R effective is equal to 7.95%. 7.95%. So here we can see that for 8% effective, the effective interest rate is 8% itself, and when 7.8% is compounded semi-annually, we get the effective interest rate as 7.95%. So better investment is 8% effective. So among these two, 8% effective yields more interest. So correct option is option 1. Therefore, 8% effective yields more interest. Now we have an example question. Mr. Y has two investment options, either at 10% per annum compounded semi-annually or 9.5% per annum compounded continuously. Which option is preferable and why? So there are two investment options. The first one is 10% per annum compounded semi-annually and the other one is 9.5% per annum compounded continuously. We need to find which is a better option by finding the effective interest rate in each of these. So first, when compounded semi-annually, we have R is equal to 10% or it is 0.1. When it is compounded semi-annually, then we have M is equal to 2. Then R effective is equal to 1 plus R by M the whole raised to M minus 1. So it is 1 plus 0.1 by 2 the whole square minus 1. Or it is 1 plus 0.05 the whole square minus 1. It is 1.05 the whole square minus 1, which is 1.1025 minus 1. This is 0.1025. So in this case, the effective interest rate is 10.25%. Next, we have the option 9.5% per annum compounded continuously. When compounded continuously, R is equal to 9.5% or it is 0.095. We have the effective interest rate as e raised to r minus 1, or it is e raised to 0.095 minus 1. Now this e raised to 0.095, it is equal to 1.0996 minus 1. So it is 0.0996, which is 9.96%. So here R effective is equal to 9.96%. So when we compare these two, the first option is a better investment option because the effective interest rate is more. Therefore, first option is better. I hope this video was useful for you. Thank you for watching.